Well, hello everyone, this is KP the Math G. Been having a few things to do over the last couple of days, and I've got a couple of greenhouses I've been working on, and at the same time I thought my camera was charged up, but no, I had to charge it up. So everything's working well now, and we're ready to go again. 94th video this one is. I'm very excited about it. For a little while we will be doing some problems that are not exactly on the test, but that are also, well, they will be on the test. They're just textbook type examples. I want to talk a little bit about this morning about L'Hopital's rule. Alright, and so with that in mind, I wrote some notes down about it. They would come in the form of, and I think you already know this, the numerator. If you're taking a limit, the limit of the numerator is 0 and the limit of the denominator is 0, it's going to be in that form. Or there's several forms, but usually I think in the AP we probably run into this one more frequently than any of them, but this one is also available, and others as well, but we're not going to get into all others. We just want to get into these two here. Alright, so let's take a look at some examples. Now, I will say this: there are times when you do not need to use L'Hopital's rule, even though you know it's possible that you could. For example, if I had the limit, and I think we've done limit from way back, I don't know which is one of my earliest videos, but if I were to do something like this, okay, and then, well, surely if I plug that in right here, this would be 0, and of course I would say this would be 0 too, because negative 1 squared is 1, 2 times 1 is 2, 2 minus 2 is also 0, and I believe you could probably do L'Hopital's rule there if you wanted to, but you don't have to. Okay, let me show you what you could do, and you're probably on top of it anyway. What you need to do is just simply factor, right? Yeah, you knew that, didn't you? Just simply factor. So if I had 2, and then 2 times x squared is x squared, 2 times 1 is 2, you can readily see that we can factor this again, and we would get, alright, 2 times x plus 1, x minus 1, and then we see that that divides out, and now alright, and just simply put the negative 1 in there, and we get 2 times negative 2, which equals negative 4. And we know that, right? I mean, that's something that we could easily do. And probably another type that we could do that you're probably familiar with And I really didn't want to spend a whole lot of time doing these types, but maybe I'll just set it up and then you'll see what I'm talking about. If you have something that has, okay, this situation here, and of course x approaching infinity, you're looking for probably infinity over infinity. Okay, that's probably what you're looking for on this one. And certainly if you go out to infinity on anything squared, even though it is minus 1, so you're just taking 1 away from whatever you get each time, but it's going to get bigger and bigger and bigger forever. And the same thing by doing this right here. This is infinity over infinity. But you can do something like this, and you can divide by the largest exponent, which is x squared in this case. Alright, so you do not necessarily need to use L'Hopital's rule on this one either. X squared, like that. You're familiar with that, aren't you? 2x squared, x squared minus 1 over x squared. Okay, and notice that each time these are gone, and of course this limit is all here. Alright, these are gone here, and these are gone here, and of course you know what happens to these as x in a denominator gets larger and larger and larger and larger. This approaches 0, right? So really this is equal to 3 over 2. So this does approach a limit, but again, you do not need L'Hopital's rule. There are cases that you're not going to be able to get either one of these scenarios though. Okay, you cannot do this or the other example, and so that's when we have L'Hopital's rule. Okay, so let's start with one right here. If I were to say the limit as x approaches 0, and I come up with e, okay, let me see here, yes, e to the 2x minus 1 over x. We know that both of these will turn into 0. This will be a 0 over 0 scenario. Well, if I plug 0 here, 2 times 0 is 0, and e to the 0 is 1, and 1 minus 1 is 0. And of course this is 0, so this is 0 over 0. So anything with e like this, well, we can't do anything except apply L'Hopital's rule. And what is that rule anyway? Well, it means that we take the derivative of the numerator and the derivative of the denominator. So if I have, for example, a limit as x approaches, well, we can say 0 or a, and we have f at x over g at x, and we find that that f at x over g at x is 0 over 0. I know I'm talking fast. Then we can just simply take the derivative of that and just keep taking the derivative if necessary until we come up with a limit. Okay, these are called intermediate, 0, 0 or infinity over infinity. So they do not guarantee a limit exists, nor do they indicate what the limit is if one does exist. So we do need to reveal it through L'Hopital's rule. Alright, we can bring that out. Alright, so let's try this one. You know what the derivative of e to the 2x minus 1 is. The derivative of e to the 2x minus 1. E to the 2x is e to the 2x, but remember we have the chain rule, so times 2, and then the derivative of 1 is 0. So this is this limit as x approaches 0 is 2e to the 2x, and then the derivative of x is simply 1, right? So over 1. So now we plug this in, we get a definite limit, okay? So now 2e to the 2 times 0. This is 2e to the 1, to the 0, which is 1, so that's equal to just 2 times 1, which is 2. Alright, that's that one. Definitely L'Hopital's rule there. Okay? We can apply L'Hopital's rule. Okay. Let me give you one where I had another example like that, but let's move on very quickly, move quite along here. There may be times when we need to do this more than once. Now, again, you got to check always if you have 0 over 0 or infinity over infinity. Okay, so if you had something like 0 over 2, then you can't apply L'Hopital's rule. Okay. Now, let's get another example, and let's try this one here. Oh my, let's see this one here. The limit as x approaches 0. So we're really probably looking at 0 over 0, right? If we plug that in, e to the x minus 1 and over x squared. If you just had x, you only have to do this one time, but boy, if we had x cubed, we'd have to do this probably 3 times until we finally get down to a 1 here. You see what I'm talking about? Alright, so the derivative of e to the x minus 1, you know that's e to the x minus 1, right? Because the derivative of e to the x is e to the x, and the derivative of x is 1. So the numerator is, now of course if we take the derivative of this, then we're saying that this is e to the x minus 1 over, now the derivative of x squared is simply 2x. So we still have 0, I do believe. We plug the 0 in. This is 1. 1 minus 1 is 1. It's like the last example, right? Alright, so, really and truly, these should be in parentheses. Some people get careless with that, and I don't know. Maybe you don't have to worry about it anymore. I don't know. Now, we know what's this numerator here, derivative. I think on the AP exam, you need to show that you are taking the derivative each time. So I'm just alright, this is e to the x. Now the derivative of 2x is just 2. And now I can plug that in, and you can see that that's 1/2. So this is equal to e to the 0 over 2, which is 1 over 2. And we do have a limit there. So sometimes you may have to do that derivative more than one time. One final example. Okay. Alright. I appreciate everyone tuning in very much. Okay, now let's go ahead and do one final example. Let's look at a limit as x approaches infinity, and we got this kind of scenario here: 4x cubed minus 6x squared. Well, that is infinity already, even though this is minus here. This is likely going to increase faster than this. Eventually it will. And adding 1 is just a little more. Okay. And the same thing here. Now, yeah, like that. Okay. You see that? Now that is, you got that cube there, and that's going to take a little while to get that down, isn't it? Okay. Alright, so now I'm not so sure if you shouldn't put a little prime over here like that. I don't know. So anyway, alright, so let's just go ahead and take the derivative up here. 3, maybe you could say applying, you might want to put on the side L'Hopital's rule. Alright, maybe you need to say something like that when you're taking your exam. I think when I sat in on those, teachers met from all over, and we sat in on these classes like this, and this is kind of what you want to say each time, maybe, or from here down, applying L'Hopital's rule. Right here, from here over. And that will give you the points, I think. So I don't know if that's changed or not. So anyway, I think you do want to show that you understand that this is L'Hopital's rule. Okay. Alright, so anyway, this is now 12x squared minus 12x, and this is 0 on the end. Okay. And then this is what, 6x squared minus 10. Alright. And again, applying L'Hopital's rule here. Alright, that's what I'd do if I were you. That way at least they know that you are applying L'Hopital's rule and not just remanipulating the problem. Yeah, you're manipulating it, alright, but by L'Hopital's rule. Okay. Alright, again, here we go again, 24. Let's keep going. You realize that this is not done yet, right? 24, let's see, x minus 12. Now these x's we're getting from a cube to a square. Alright, here we go. This is 12x. Oh, that's it, 12x. Alright, I'll put that in the middle. Okay, 12x. Alright, there we go. And then applying it one more time, that would be the limit as x approaches infinity. Now this is definitely going to be 24 minus 0, which is just 24. And then over, 1 times 12 is 12, and that's just a long way of saying that we do have a limit with that. It is too. Okay. And yeah, that's it. It's just showing you that sometimes, you have to keep going over and over and over. And just remember, I think I erased all of the other ones. Yeah, well, I didn't even flip the board, did I? Yeah, I just kept erasing. Okay, so there are times when you do not have to use L'Hopital's rule. Alright, and there are times, you probably could use it either way. If you get 0 over 0, yeah, you can still go for it. You can still do that. So anyway, just kind of keep in mind that let me show you something. Maybe if we have something like a limit as x approaches, let's say 3, x squared minus 9 over x minus 3. We know that 3 minus 3 is 0. 3 squared is 9, and 9 minus 9 is 0. So Yeah, you could probably still apply L'Hopital's rule. So let's see. And again, I would say applying L'Hopital's rule right from here. Okay, I would say x approaches 3. Let's see if we try that. That's 2x. Oh, that's just 2x, isn't it? Alright, over 1. Alright, and then 3 times 2 is 6. So 2 times 3 is 6. So yeah, there it is. And it would give you the same answer, I believe, if you went ahead and did this. Okay, let me erase this side here. I hadn't done a video in so long, I want to just keep going, I know. But I know my camera will stop me if we run over 30 minutes. Well, 31, 32. Alright, let's see if I have enough. Let's see. The limit as x approaches 3, x squared minus 9 over x minus 3. Alright, that's equal to, alright, so we could say the limit as x approaches 3, and again, factoring x plus 3, x minus 3 over x minus 3. Alright, now, okay, so the limit as x approaches 3, x plus 3, now I can plug that in, 3 plus 3 equals 6. So either way, we get the exact same answer. It works both ways. I mean, if you get 0, 0, this happens pretty fast, doesn't it? You may not think to factor this. So, I mean, you still have L'Hopital's rule, don't you? Alright, so that's what I'm talking about here. You can use L'Hopital's rule. But again, be careful. If this is not 0 over 0, you cannot use L'Hopital's rule. Okay. And that's all that I have for right now. I appreciate everyone tuning in to my videos. I've been wanting to do another one sooner. My camera was dead, the battery was going, well, not completely dead, and so I did have a couple chores to do. We're trying to get the ground. We got grass growing inside of the greenhouse. I want my greenhouse to grow green vegetables, not green grass. So I had to hoe that out. So my wife and I had a hoe each, and we just got after it. Actually, I got the tiller and started tilling that stuff up. It was so much easier to do it that way. And then we hoed around the edges. And so now we got a flat ground of dirt. That's really nice. But anyway, excuse me. That's, I tell things every once in a while. But anyway, that's what we've been doing. And this is really nice here. I still believe this is the AB part of it. I'm going to get into some BC material a little bit later. And then if you want to do one of these questions again, let me know. And I'll stop doing this for a little bit and go to some questions again. I know your test is coming up in May, probably, I believe. And you do have a mock test coming up, and probably in March. So if you're in the AP, the BC, AB or BC, you do have that coming up. If you're taking calculus, just straight calculus, hey, you're in for a treat. We got some more stuff to give you as well. And I hope this is helping you understand this as well. Okay, please subscribe if you have not done so. I appreciate you subscribing. And also, if you'd like to hit that like button, KP the Math G just loves that like button. If you would like to make a comment, please make a comment. So I appreciate all of those things, because you are important to me, and me giving you a quality product is what I'm all about. Alright, KP the Math G signing off. Guys and girls, ladies and gentlemen, have a great, great day.